So let's have a look at what we are going to be digging into this evening. Okay, so as I said, we're going to be having a look at the camera's light meter, how your camera's light meter work. We're going to be diving into this term you may have heard before, certainly will expand your photographic vocabulary as well, called stops of light. And stops of light are very important to understand when it comes to creating our own exposures, and as I said, this is going to be fundamental for lesson 8 this week as well. We're going to have a look at our aperture value mode and our time value mode again. We're going to see how the light meter works in those modes, because I know after lesson 4 we had loads and loads of questions about what happens to shutter speed and what happens to aperture when you're using either one of these modes. And we're going to have a look at exactly what happens to the other function if you're shooting in aperture, for example. What happens to your shutter speeds, or if you're shooting in time value mode, what happens to your apertures. Then we'll have a look at some issues you may encounter as well and how you'll also overcome them. And if you're still if you are shooting in your TV, your AV modes, we'll also have a look at what exposure compensation is as well. And this is an incredibly useful tool to be able to use. Okay, Lisa, you're asking, do we have to be on live to lesson 8 to be eligible to win? No, that's absolutely fine, Lisa. Once you've been attending the lessons up to this stage, you will be in the draw for that as well. So don't worry about that. I hope everything will be okay with you there as well. Now, and we'll have our summary and Q&A and everything as usual at the end of the lesson. So let's get right into it, because we have quite a bit to cover this evening. Now, does anybody want to tell me what's wrong with this photograph? Okay, so just waiting on some answers to come in there. Yeah, absolutely, Getrin. It's too light, Samantha. It's overexposed, Anthony. You're right there as well, and so is Mario. It's completely overexposed. So we can plainly tell this by the amount of white there is in this photograph. And this is what we call pure white, when there's no detail in the white at all. And you can imagine the horror as a photographer if you were photographing somebody's wedding and the bride comes out like this, where you cannot see the detail in her dress at all. It'd be an absolute nightmare for a photographer. So having a strong understanding of metering and how it affects your exposure will minimize the amount of bad exposures you're going to make when shooting. As photographers, we want to be more consistent with our exposures. We want to concentrate on things like our composition and being creative. We don't want to spend all of our time trying to figure out why our exposures are incorrect. And this is crucial as well if you're ever doing an important shoot for someone like this, like if you're at a commercial shoot or at a wedding. If you get a bad exposure and you cannot diagnose where the problem is coming from, you're going to start missing all the shots. You're going to start to panic as you try to figure out why your exposures are incorrect. So a good technical knowledge will make sure that you know exactly what is happening. So when you see a bad exposure, you know the necessary adjustments that you need to make. It's just frustrating for yourself. You know, if you take a photograph like this, you know, your family, your children, and so on, and you miss a good shot because the exposure is incorrect. And has this ever happened to anybody? Yeah, absolutely, Angie, you're right. It's too dark. It's too underexposed. Yeah, and this is something that happens to every single photographer. Unfortunately, at one stage or another, you just get exposures wrong and you don't know why they're bad or why they're wrong, and you start missing the shots that you're trying to capture. So it's an incredibly frustrating experience. So then you're going to spend endless hours in post-production trying to fix things that you should be able to get right in camera. Okay, so and I can see Agnieszka just saying that there. Is it something that we can fix in post-production? If this is something we can fix in RAW? It is, absolutely, Agnieszka. We can fix these kind of things. But you don't want to be spending hours in post-production fixing things that we can get right at the time of the exposure. I mean, how many of you end up spending too much time tweaking and correcting exposure? And as photographers, you know, this is, and especially even just for myself, this is something I'm guilty of too. You spend so many hours just tweaking the smallest little changes in your work afterwards, and you could be spending that time being out there shooting instead. You know, so we want to always have the best knowledge at the time of shooting, so we can use image editing tools as a creative process. And you know, post-production should be a creative experience. It shouldn't be a process of fixing our mistakes. So as I've said before, the more technical abilities you'll have, the more confident you are going to be out there shooting. And as I always say, a confident photographer is a photographer that is going to take the best photographs. Okay, so let's get right into it. Good exposure is all about getting the right amount of light into the camera so that the image is at the right level of brightness. That's what we would call a good exposure. Too much light and the picture will be overexposed, as we saw a little bit earlier. Not enough light and the picture will be completely underexposed. You'll lose all the details in the shadows and in the blacks. So how do you or the camera know exactly how much light is enough? How do we know when we have the correct amount of light in the scene? Well, lucky for us, our camera has a light meter to measure how much light is coming into the camera. When we are in any automatic function or any semi-automatic function on our camera, every time you press the shutter halfway down, the camera's light meter starts to measure how much light is coming into the camera. And it comes up with a shutter and aperture combination required to get the correct amount of light into the scene and get the right exposure. So the camera is constantly calibrating and coming up with combinations of our apertures and shutters together to make sure the correct amount of light is coming into the scene. It'll display the shutter speed and the aperture settings that it's using on your camera's LCD or in your camera's viewfinder so that you can see the settings yourself. It'll always tell you what the settings it is or it's using to get the correct amount of light in the scene. So if you're ever using an automatic or a semi-automatic mode and you're wondering where the camera is getting the shutter speeds and the aperture settings that it's displaying, it has chosen these because these are the combination that best works to get the right amount of light for you. Okay, and this is what happens when we shoot an automatic. Our camera just wants to get the exposure correct, okay? It just wants to make sure the correct amount of light is coming in. So we can see where our shutter speed is displayed. We've looked at this before. We can see where our aperture is displayed as well. So in this case, 125th of a second and f5.6 as well. Now, it does take in, Michael's just mentioned, that does not take into account the ISO 2. It does take into account ISO 2, but let's imagine for the moment we're only dealing with apertures and shutter speeds. ISO does play its part, but we'll look at that in lesson 8. Okay? So, to see this in action, you can try this out yourself. Put your camera into the P mode or the program mode or even into the fully automatic. If you point your camera out the window where it should be a little bit brighter or perhaps darker, it absolutely depends on what time of the day it is, wherever you are watching this in whatever part of the world you're in. But generally, if you point your camera at something brighter and then point it at something darker, you're going to see the camera's settings change. Okay, so you're going to see a big jump in the change in terms of the exposure, the aperture, the shutter speed combinations that the camera is using when you point it at something bright or when you point it at something dark. So try this out yourself. You don't have to try it out now straight away. If you happen to have your camera on you, just put it into the program mode and point it at various different light sources to see the different exposures being calculated. The light meter is constantly recalculating. The combination of settings that the camera comes up with comes from how much light is in the scene that you have the camera pointed at. And the amount of light that's in the scene is measured by the camera's light meter. So as we saw back in lessons 3 and 4, aperture controls the volume of light coming into the scene or into the camera, and the shutter controls duration, the amount of time that the light is coming into the camera as well. So the camera utilizes both of these mechanisms to make sure the correct amount of light is coming into the camera for you. And that's why you see these two values changing as you move the camera around. Okay, so when we talked how we see, back in lesson 3 with Thomas Woods, he was speaking about, we looked at how light comes in from the sun or an artificial light source, reflects off the objects around us and enters our eyes, allowing us to see. Now, To throw a curveball at you, most scenes in the world only reflect about 18% of the light that is hitting them. So most things that we look at reflect 18% of the light that's hitting them. Now, why do we need to know this? Well, this concept applies directly to photography and particularly to how the light meter works. The light meter is geared to think that the object in front of it is reflecting 18% of the light that's hitting it. So if your light meter works off this concept, then it's making pretty accurate readings about how much light is in the scene. So to clarify that, to make it simple, essentially our light meters are calibrated to think that every object that is in front of us is reflecting 18% of the light that hits it. Does that make sense? So it's a physics thing in terms of why it's only 18% of the light that's being reflected off the majority of objects, some of the light's being absorbed, the majority of the light's being absorbed, and only 18% of the light is being reflected. Like in this example, like this branch, sunlight hits the branch and only 18% of the light bounces off the branch, allowing us to see. And our camera's light meters are calibrated to think this way as well. Okay, so for most scenes in the world, this is a safe bet. So the majority of scenes in the world, this is a very, very safe bet for the light meter to make a good exposure for you. Okay, different amounts of light requires different exposures, but your light meter always makes the assumption that the camera needs exposure settings for a scene reflecting 18% light. Okay, for most occasions this will work out fine, but there are going to be some times when the meter will get this wrong and you need to override these settings, and we'll look about that a little bit later on. For example, Liam has just given a great example, which is snow. What about snow? Does snow reflect 18% of light? No, it certainly reflects more. And that's one of those situations, Liam, where this principle doesn't work. But we'll have a look at how you can compensate for that a little bit later on. But the majority of the time, the majority of things that we look at through our camera, 18% of the light is being reflected off them, and our camera's light meters are calibrated for that. Has anybody ever heard the term 18% in relation to a little bit of photographic equipment before? There's a particular bit of photographic equipment that 18% is very much associated with. And I'll be interested to see if anybody gets this one. I saw someone mention it there a little bit earlier on, so just waiting for a couple of answers to come in on that one. Excellent, yeah, I see lots of correct answers coming in there now. 18% grey cards. So you may have heard of a grey card before, and we'll have a look at those a little bit later. But a grey card is calibrated for 18% as well, because it's calibrated for your camera's light meter. And photographers will use grey cards. If they're having trouble getting an exposure, you just expose off a grey card instead. Don't worry if you haven't heard of them before. They're actually not used as much as they used to be. Certainly with film photography, they were very, very important. But they're still very, very relevant with digital photography. But it's obviously a lot easier as digital photographers to adjust, because we simply look at our camera's LCD and make a change if we need to. But we'll have a look at those a little bit later on and explain how they work. So, based on this concept now, we'll come back to that a little bit later on. But I want to discuss how light is measured and quantified. So there's a particular term that we use as photographers, and I want you to start using this term as well when it comes to exposure. The term stop. Stop comes up regularly in photography, and we've already seen it in relation to apertures and f-stops, okay? And we saw it'll be different, that was for apertures. In lesson 4, we talked about f-stops. But stops is also a term that's used in relation to our shutter speeds, and indeed with ISOs when we look at those in lesson 8. We'll return to this in lesson 8 in a little bit more detail, but for now, the term stop is something you should become familiar with. Stops are the language that your camera speaks in. Okay, so a stop is in photography refers to a measure of light. A stop is either doubling or halving the amount of light in your scene. Anytime you double the amount of light getting to the camera sensor, you are increasing the light by 1 stop. Okay, so if you've heard a photographer or anybody say before, oh, I added a stop to that exposure, that meant that they were doubling the amount of light getting into the scene. Anytime you have the amount of light getting to the camera's sensor, you are decreasing the light by one stop. Okay, so increasing by one stop means you're doubling the amount of light coming into the scene. Decreasing the light by one stop means you're halving the amount of light coming into the scene. So let's see this in action. So have you ever seen this on your camera before? And my apologies about the low resolution screenshot here. But have you ever seen this little dial, this little indicator? You might have seen it on your camera's LCD. You may have seen it in the light meter as well. Or sorry, in your camera's viewfinder. This is your camera's light meter. Okay, so if you've ever wondered what this little guy is, this is your camera's light meter. So if you weren't sure what this is before, this is what you use to gauge the exposure in photography. Okay, so let's break this down. And Emma, you're just asking, how do you alter the stops? Well, this is exactly what we're working up towards, Emma. We're going to be having a look at how you can alter the stops through your semi-manual modes, but also through the fully manual mode as well. So, your camera's light meter displays light in terms of stops. So you may have one that says -2 to +2. Some will go beyond that. They'll say -3 to +3. But the concept is the same, regardless of how many numbers are displayed in that. They're all displayed as stops. Okay, so it has a scale with a 0 in the center. We've got a -1 and a -2 to the left, and we've got a +1 and a +2 to the right. What the 0 represents here is when the camera is receiving enough light based on that 18% reflectance. So if the 18% reflectance is still too complicated, don't worry, I do understand that this might be a totally new concept. But to simplify it, for now, you could just think of 0 on the light meter as the point when the camera is getting the correct exposure. Okay, so does that make sense? 0 is essentially what the camera assumes is the correct exposure for the scene. So when the light meter is at 0, the camera is assuming that this scene has the correct amount of light. And if we were to take the shot, we should have the correct exposure. And this is going to be fundamental when we look at fully manual in lesson 8. Essentially, we want to try and get the light meter to 0, as 0 is assuming that this is the correct exposure. Okay, so let's break this down a little bit more. The +1 on the light meter is an indicator that the camera is getting one stop more light than what the meter is saying would be the correct exposure. So basically, when the meter is displaying +1, there is twice as much light getting to the camera sensor that is needed to expose the scene. So remember, +1 stop is doubling the amount of light coming into the scene. Okay? So if we were to go to +2, this is a bit of a tricky question. If we were to go to +2, how much more light is coming into the scene then? Okay, a bit of a tricky one. So remember, +1 is doubling the amount of light. So what would +2 be doing? How much more light would be coming in at +2? So the +2 on the light meter is an indicator that the camera is getting 2 stops more light than we need to correctly expose the scene. Just waiting on a couple of more answers to come in there, but I can see the majority of people are getting it right. Okay. In this case, when the light meter is displaying +2, there is 4 times more light coming into the camera's sensor than is needed to correctly expose the scene. It doubles again. Okay, so it doubles again. So if we have 1 stop that equals double the amount of light, 2 stops is doubling that again, and it means that there's 4 times more light coming in than is needed to expose the scene. So we want to adjust in this case to get the light meter back to read 0 to make sure that we have the correct exposure. So let's have a look at this. So we'll just review that, sorry. So +1 is double the amount of light getting to the sensor than is needed to correctly expose the scene. +2 is 4 times the amount of light getting to the sensor than is correctly needed to expose the scene. Does anybody want to tell me what would +3 stops, if we were reading +3 stops, how much more light is coming into the scene then if we were at +3? So remember, +1 is doubling the amount of light, +2 is doubling that again, so it becomes 4 times the amount of light. So what would +3 be? Okay, excellent. I can see Dave's got it right. Fantastic. Charles, you're correct there as well. Fantastic. Yeah, you're absolutely right, guys. 8 times the amount of light would come in then, because it doubles again. It doubles again. So it would be 8 times more light coming into the scene. It would be completely overexposed at that stage. You can imagine if we have 8 times more light coming into the scene than we need, it would be completely washed out at that particular stage. So it doubles each time. 1 stop is doubling the amount of light coming in. 2 stops doubles that again, and so on. Okay, so does that make sense so far? Excellent. Brilliant, brilliant. And we'll have a look at some visual examples of this in a moment as well. So don't worry if you're not too sure. As photographers, as I always say, we're visual creatures. So we'll have a look at some examples of that, and it'll make a little bit more sense. So let's have a look at this at the other end of the scale. So we have seen how a stop is doubling or having the amount of light getting to the camera sensor, with 0 being the correct exposure. But do any of you guys want to take a guess as to what -1 represents on the light meter? Okay, so +1 is doubling the amount of light. What would -1 mean then? Fantastic. Yeah, I think everybody is getting this concept. Anytime we see the light meter reading -1, then there is half the amount of light getting to the camera sensor than is needed to expose the scene. So essentially our picture is going to be half the brightness level than it should be. So it's the opposite. Half the amount of light is coming into the scene at -1. So you could probably hazard a guess then at -2, and I think you guys are really starting to see the pattern forming here. So when we would see the camera's light meter displaying -2, we would know that there is 4 times less light coming into the scene than to correctly expose the scene. So 4 times less light coming into the scene. So it's half and then half again, which is 4 times less light than is needed to correctly expose the scene. And that is how our stops work. So I want you to get familiar with using them. Okay, so let's just summarize that again. Stop is half the amount of light getting to the camera sensor than is needed to correctly expose the scene. -2 stops is 4 times less light coming in to correctly expose the scene. And then again, -3 is 8 times less light coming in to expose the scene correctly. And again, you can imagine at -3 stops just how dark the exposure is going to be. So if you see your camera's light meter at -2, you know that you're going to have to change the exposure and let 4 times more light in to get the meter back to 0. So let's make this more visual, so just to understand a little bit more clearly. So here we have a simple image of a grey brick wall. Hardly the most exciting photograph you're ever going to see in your life, but a very good one to illustrate this example. If the camera's light meter, or if we point the camera at this and the light meter is at the center reading 0, then we'll get this image. The greys are represented as grey, and the image represents how the scene looked at the time. This is what we would call the correct exposure. Okay? Now, the correct exposure is subjective. When I say the correct exposure, I am simply talking about capturing the light as it was at the time, based on this concept of 18% reflectance coming off the scene that we are shooting. So based on that, when the meter is at 0, when the light meter is at 0, it is the correct exposure. And in general, when you have the light meter set at 0, for the majority of scenes, that's going to give you the correct exposure. Now let's see what happens if the camera's light meter is indicating +1. Okay, so we remember at a +1 exposure, we're doubling the amount of light coming into the scene. And you can see what's happening here now. the greys are becoming much more lighter and they're beginning to get more overexposed. Okay, we haven't lost the detail in the scene, but remember that's double the amount of light. Twice as much light is now coming into this scene as then in the previous photograph. Okay, and then if we go to +2, remember at +2 it's getting very overexposed. Very, very overexposed. We know at +2 the greys have gotten so bright that they now look white in tone, and again, they don't represent the tones as they should be in this scene. That's because there's 4 times more light than is needed to correctly expose this scene. So there's 4 times more light coming into this scene than we need to correctly expose it. And again, if we go the other side of it, here we have an underexposed version of the photograph. So at -1, underexposed, that means that the camera is only getting half the amount of light necessary to capture this image accurately. So only half the amount of light is coming in to get this compared to our correct exposure. And you can see that the greys are getting much darker and duller. There's an overall sense that the image is very, very flat and the image is very, very dark. Okay. Now you might prefer this exposure, and I can actually see a couple of students saying that, all right, that they actually prefer the slightly darker exposure. But it is important to understand how to capture it as it is before making these creative decisions about whether you want to underexpose or overexpose a scene. And there is going to be instances where you might decide you want the scene to be a little bit darker, and you might want the scene to be a little bit brighter. It absolutely depends on what you're shooting. Okay, and then at -2, the camera is getting 4 times less light than it needs to expose this scene accurately. It's becoming very, very dark. So there's 4 times less light coming in now. And the greys are now almost becoming entirely black. The image is very dull and flat. We're beginning to lose some detail in the photograph. Any further underexposure, and all the detail will become so dark that it would become solid black. Okay, so does that make sense, guys? I know this might be an entirely new concept for people, but this is how your camera's light meter works. And basically, we want to try and get the light meter to 0 for the majority of situations. If we get the light meter to 0, we're going to have the correct exposure. Now, as we'll see in a moment, having the light meter at 0 is not always going to be sufficient for every single scene, but we'll have a look at how we can adjust that a little bit later on as well. So let's just have a look at all of these different exposures together, just to put them together, and we can see the differences very, very clearly. So you can see the light meter reading settings for each of these exposures underneath. And I think everybody's beginning to understand this mode, understand this light meter. So in the auto modes and the semi-manual modes, you will not see the light meter change. And I'll just repeat that. When you're photographing in auto and semi-manual or semi-auto modes, you will not see the light meter change. It is stuck at 0. And the reason for this is that the camera wants to get the correct exposure. That is all it knows. It just wants to get the correct exposure. Okay, it does not know what depth of field you want. It does not know what shutter speed you want. And these semi-auto modes are useful. But what's the problem with them? Does anybody want to tell me what's the problem with these auto and semi-auto modes? Okay, just waiting on a couple of responses there. Yeah, absolutely spot on, guys. We have no control. We have absolutely no control when we're shooting in these semi-auto modes. Okay, sorry, my slideshow disappeared there for a second. So in fully manual, the camera does not lock the light meter at 0. Okay, so when we switch to, if you were to try it now, you could switch the camera to your fully manual mode. You'll see that the light meter begins to change as you move the camera around the scene. Okay, the camera does not lock the light meter at 0. The meter will move as we change from scene to scene, from light source to light source. We have to adjust the settings on our camera to get the light meter back to 0, to get the exposure correct. And that is what we will cover in lesson 8. But for the moment, let's have a look at aperture value modes and time value modes and see how they work in regards to exposure. So is everybody still with me before I move on? Excellent, guys. Excellent. I'm just going to mute myself for just one moment there. I'm just going to grab a very quick sup of water. Sorry about that, guys. Can everybody hear me there again? Fantastic. My apologies about that short break. So to continue on, so we're going to have a look at how exposure works in our semi-manual modes, in our aperture value mode and our time value mode as well. So in aperture value mode, you take some control over the camera's function. And in this mode, as we know, we are able to change the aperture. So we can control the depth of field in our scene. But in this mode, the camera does all the settings to try and maintain the same level of light for you and make sure the exposure always stays the same. So if you ask the camera for a certain aperture, how does the camera make sure that you are getting enough light for the correct scene? What does the camera change to make sure the correct amount of light is coming into the scene? So remember, the aperture controls the volume of light coming into the camera, and you could ask for a very wide aperture, a very big aperture like f2.8, where the aperture hole is very large, or you could ask for a tiny aperture such as f22, where the hole is only letting a very small volume of light in. So how is this going to compensate? What other part of the camera is it going to change to make sure the correct amount of light is coming in? Yeah, absolutely. For all of those who said changing the shutter speed, you're absolutely correct. In order for the camera to accommodate the different size apertures, it'll change the shutter speed. It'll change the duration of time to allow more or less light coming in, depending on the aperture that you have chosen, okay? So you lose control over the shutter speed when you are photographing in your aperture value mode. So let's have a look at some examples of this. Okay, so here we have a scene where the camera is in aperture mode, and I have asked for the camera, we've seen this guy before, okay, I've asked for the camera for a very wide aperture, okay, so the camera has gone ahead and picked its shutter speeds to get the right amount of light to make sure I've got a good exposure. So shooting at f2.8, that lets in a lot of light, but as we also know as well, it's going to create a very shallow depth of field too. Okay, when it does that, it's decided that it's going to choose a shutter speed of 125th of a second. And that is going to give me the correct amount of light for this scene. Now remember, I'm only controlling the aperture. The camera is making all the decisions in terms of what shutter speed I should be using. I have no control over the shutter speed in this case at all. So what happens if I change that aperture? So I've decided I want to capture the same scene with an aperture of f11 instead of f2.8. And this could be simply because we want more depth of field in the scene. Okay, so I want to increase the depth of field. I want to make the people, up to the lady here, sharp and in focus as well. Okay, so because we are in aperture value mode, okay, the camera is going to try and help us maintain the same exposure and keep the correct amount of light in the scene, and it does this by increasing the shutter speed, making the shutter speed slower. And you can see now it's gone down to an 1/8 of a second. So when I close down to f11, we can see it's closed it all the way down to it's made it down to an 1/8 of a second, which is, and Jim has just said it there, you can't handhold that. So that becomes a problem. That certainly becomes an issue. And this is something that you need to be very aware of when you begin to change your apertures, okay? You're going to have to pay close attention to your shutter speeds. And let's take that to the extreme. So say we were to go all the way down to f22, because we want to get everybody in focus. We want to get everybody nice and sharp in the scene. But now you can see that we've gone all the way down to half a second. We've gone all the way down to half a second in this case. And for sure now, what might we have to use in this particular situation? We're definitely going to get camera shake, so what item might we use to help us compensate here? Excellent. Yeah, Rianne, you're in there straight away. Yeah, absolutely. And everybody's saying it there now. We'd need a tripod in this particular case. Ian just said a tripod might help. It would definitely help Ian in this particular instance. So this is something you need to be aware of when you are photographing using your aperture value mode. When you start to close that aperture down, you need to pay close attention to your shutter speed because it's always going to compensate to make sure you have the correct exposure. Does that make sense, guys? Brilliant. Brilliant. Fantastic. Great stuff. And I know I had loads and loads of questions about this after lesson 4. So if you're not sure, but I see some questions coming in about aperture priority mode and time value mode, please go over lesson 4 if you haven't seen those lessons as we dive deep into those modes in that lesson. Okay? So let's have a look at this in terms of our shutter and our time value modes. And I'm sure you got a sense of this as well, how it works in these modes too. But just to see what is happening in this other semi-automatic function, the shutter priority, our time value mode. Remember, in this mode, we are controlling our shutter speeds. Okay, so it might appear as S, it might appear as TV, but we know in this mode that we are controlling our shutter speeds in this one. We're picking the duration of time. So if we want to control the motion in our photographs, we might select this mode. But what do you think in this mode is the shutter, in shutter priority mode, what is the camera going to control to make sure we have the correct exposure in the scene? So what other function is it? And Sharon, you're right in there as well, Steve, Kev, Tomas, yeah, absolutely. Yeah, brilliant. We're going to control, it's going to take control of the aperture. We're going to lose the control of the aperture on our cameras when we use this particular mode. Okay, so let's see that in action. So here we have an example where the camera is set to the shutter priority mode, and as we know, we're in control of the shutter speed now. So in this particular shot, I've decided that I want to have a little bit of movement, a little bit of motion in this water. So I've decided to select a shutter speed of a 15th of a second. A slow enough shutter speed. It might seem quite fast, but it's actually quite slow in terms of in terms of speeds for photography. So 15th of a second is giving me a nice little bit of movement in the scene, and we can see that the camera has decided to select an aperture of f16 to make sure that the photograph is not overexposed or not underexposed, that the correct amount of light is coming into the scene. Okay, so then if I decide that I want to make the shot a little bit faster, I want to try and capture that movement, I want to try to freeze that movement a little bit more, I decide that I'm going to change my shutter speed to something much faster, and I go to 125th of a second, 125th of a second, and as we can see now, to compensate for this, to make sure the correct amount of light is still coming in, it's changed the aperture to f5.6. It's opened up that aperture wider to make sure more light is coming in. And it does that because I have made my shutter speed much faster. Okay, because I made my shutter speed from a 15th of a second to 125th of a second to compensate for this, and it's a big change. It opens up that aperture more. It makes that aperture wider so that more light is coming in to make sure that we get the correct amount of light. And Steve, you're just saying it also affects the depth of field as well. And yeah, you're absolutely right, Steve. So just like we saw with the previous example with our shutter speeds, you do need to pay attention to this as well. So if you're changing your shutter speed, and say we change it here again to 500 of a second, it opens that aperture even more. And when it opens your aperture that wide, you do need to be aware of your depth of field as well. Now, in this particular case, it's absolutely fine and quite close to the subject. It's not having too much of an effect on the shot, but in certain instances, you will need to be aware of this. At 500 of a second, it's very, very, very fast. And as you can see with the water, it's frozen. It's been captured. We can see all the individual droplets. But now you can see that we need a very wide aperture of f22. Okay? So does everybody understand that, how this works? So when we're shooting in our semi-manual modes, our aperture, our shutter speed modes, be aware of what the camera is controlling. It's controlling either your shutter speed or your aperture. Pay attention to them. Your camera will still show you what shutter speed and aperture settings that it's using. So do pay close attention to them. You want to make sure that if you're in aperture priority mode, that your shutter speed doesn't go too slow. And similarly with your shutter speed, when you're going very, very fast, you want to make sure that that depth of field does not become too shallow for you. So we can control this though as well. So we do have a little bit of control over this too when we're shooting in shutter priority mode and time value mode as well. So we'll have a look at that in just a moment. But now that we understand our light meter a little bit more, okay, and I know it's a new concept, this one might take a little bit of getting used to, but we do need to be aware of some issues that you may encounter with your light meter. And I think it was Steve who mentioned snow earlier on. It was Liam, you mentioned snow earlier on. And there are certain scenarios that we will encounter where having the light meter set to 0 simply is not going to give us the correct exposure. So the problem with this idea that the camera assumes that everything reflects 18% of the light that hits them is this is not true for every single object or every single scene that we photograph. What it means is that the camera treats all tones as if they are the same. It treats every single scenario that we encounter as if it's the exact same. So when it sees a scene of perhaps all black objects, it assumes that the amount of light that is needed to expose this scene is the same as if we had a scene of all white. Okay, so it exposes both scenes the same. And this can be very problematic and it can cause all the images to be under or overexposed when we are dealing with light and dark scenes. So let me just clarify that. Imagine you're photographing something incredibly dark and there's lots of deep, dark black tones in it. And then imagine you're photographing something very, very white, like a snow scene like Liam mentioned earlier on. Do you think that they are going to need the same exposure to get them correct? They're very, very contrasting scenes. Lots of no's coming in. You're absolutely right. You could not treat those two scenes the same way. They're so contrasting in terms of how you will photograph them. So how can we compensate for this? Okay, well, let's have a look at this. Let's break this down, first of all. So here we've seen an image that we saw in a previous lesson. I think it was back in lesson 2, if I'm not mistaken. But in this case, we got a black object on a black background. Very, very nice camera here, a nice Hasselblad camera. So in this particular image, we can see that the tones are pretty close to black, and they closely represent what this object would look in real life. So a nice black object which is full of black tones but still loads of detail. It's not overexposed and it's not underexposed. We'll have a look at how the camera meters for this scene in just a moment. Here we have the opposite scene. So just like I was saying, the complete opposite. We have a white object on a white background. Now, in this scene, all the whites look bright white, but the object still has enough detail to see and separate it just about from the background. Now it's verging a little bit on overexposed, but it's not complete, it's not overexposed. Linda, you're saying you did not read my comments. Linda, as I say in every single lesson, there's thousands of comments come in, so we can't get to them all, but we will do a Q&A at the end, Linda, okay? Now, so as I was saying, here we have the opposite scene. Basically, this is bright white, but there's still enough detail. It has not been overexposed. It hasn't become pure white with detail. But nor has it been underexposed, where the whites look flat and grey and don't represent the scene as it looked in reality. So just like the blacks we saw in a minute ago, we'll have a look at how the light meter would treat this scene based on that 18% principle. So the camera assumes that these scenes are reflecting the same amount of light. Okay? So it'll try and give you the same exposure for both. So we'll just say that again because it's important. The camera assumes that these scenes are reflecting the same amount of light, but simply looking at the scenes, we know that that's simply not true. They're completely different from each other. One is deep, dark and black. The other is bright and white. Okay, so black or dark objects absorb more light than white or lighter objects. And as we know, a scene with lots of black should naturally look much darker. Whites or bright tones reflect more light than a black or dark object, so naturally a scene with lots of whites should naturally look brighter. And it's obvious that both scenes should not be treated the same in terms of exposure, and they should not look the same. A black scene should be much darker than a scene with lots of white. So let's have a look at how the camera treats both these scenes. Essentially, the camera is going to see these scenes both the same in terms of exposure. So the camera itself is a device that has no idea what tone or color it's looking at. And as we have seen, it assumes all things are reflecting 18% of light. It cannot tell the difference between a dark object and a bright object, so it treats them the same. So can everybody see how this photograph now looks grey? We know that this should be white, but it looks grey. It doesn't look correct. Absolutely, everybody can see that quite clearly. So when it comes to really bright objects like our white object on white, the camera has no idea that this is a very bright object, and it assumes that 18% of the light that's hitting it is reflecting it, and basically we end up with an exposure that looks like this. Okay, so because it doesn't know that this is bright white, it treats it the same as any other grey object. And typically it ends up underexposing whites and turning them into greys. So in this case, we see how grey our whites look. We can see how flat it looks. It just does not represent the object as we saw previously. So let's just compare the correct exposure to this underexposed shot. So here we have the two images side by side. On the left is the exposure that the meter is giving us based on the idea that all objects reflect 18% light. Okay, we can see how it's all grey, it's clearly underexposed. The camera cannot tell that this is a white object and cannot tell that it's reflecting more light, and it ends up underexposing the scene. On the right is the more accurate version of the photograph on what we would actually like to achieve. So let's just see this in relation to our other photograph, okay? And this one always interests me. So again, based on the meter's assumption that the scenes are reflecting 18% of the light that's hitting them, it's trying to reproduce the dark scene as it did for the bright scene. Now, this one catches people out a little bit more because a lot of people, when it comes to dark tones, it's a little bit harder to see whether the photograph is overexposed, okay? But here, this might look like an okay subject, but remember it's deep black background with a black object that has detail. This exposure, it looks grey. The background looks grey, the object looks grey, the camera looks grey, and it's not representing the tones as they should be, okay? So this is a little bit tougher to see, but when we compare the two photographs side by side, we can see this difference very, very clearly. So like we have seen with the whites, the camera again does not understand that this is a black object and it's not reflecting as much light as its 18% setting. Less light's being reflected in this scene. Black absorbs light. And this results in an overexposed image, as we can see here clearly on the left. As we can see, the one here on the right is what this scene should correctly look like. So you're probably asking yourself at this stage, well, what's the point of all of this? How can we adjust for this? Okay? So we can adjust for this by using exposure compensation. So exposure compensation is a terrific tool that we can use when we are using our semi-manual modes. So if you're using your aperture priority and your shutter priority and your camera is under or overexposing a scene, you might be asking yourself, how can you add more light? How can you add a stop of light, or how can you reduce a stop of light? You can do that by using exposure compensation. This is something that I really want you to get used to using if you're using your semi-manual modes. When you work on fully manual mode, exposure compensation doesn't work anymore because we're controlling the scene entirely manually. But if you're using your aperture and your shutter priority modes, this button is absolutely invaluable. Okay, so your camera has a function that allows you to override the camera's metering and purposely overexpose or underexpose your image so that certain scenes or tones closely resemble the way that they should look. So as we saw, when the meter gets it wrong, it can either overexpose the scenes with lots of blacks in them or underexpose scenes with lots of white in them. So in this situation, it's usually, it's very useful to make the camera, or we can overexpose or underexpose for us. So most cameras that have AV and TV modes will have this exposure compensation button, and it usually is represented by this symbol. So do have a look at your camera's manual to find this in your own cameras. As we always say, when you discover something new on these lessons, please refer to your camera's manual to find it on your own camera. But generally it's represented by this little plus and minus symbol. Typically when you use this function, you hold the button down and you adjust the wheel, and this will allow you to overexpose or underexpose in whatever you prefer. You'll actually see the light meter move as well when you use this function. You'll see it overexposing or underexposing when you use this in your camera. As some people were just asking there again, you do not use this mode in fully manual. Okay, so in fully manual, we don't need to use exposure compensation because we are fully controlling the exposure ourselves in fully manual, okay? But when you're using your semi-manual modes, you have this option, your exposure compensation. So if your camera doesn't get it right, if you're finding it's overexposing or underexposing the scene, you can simply add a stop or reduce the stop more light to whatever you prefer. Does everybody understand that? Excellent. Excellent. Great stuff. Do get used to it. It's a great little button to use when you're using your semi-manual modes. Very, very useful. So here's an example of what this would look like if we were to use our exposure compensation going back to these scenes. So here we can see again this photograph. When we're at 0, when the light meter is at 0, it's incorrectly exposing the scene. It's overexposing this particular photograph. So we decide to reduce it by a stop. And when we reduce it by a stop, guys, how much less light is it letting in when we reduce by a stop? Exactly, Dale, Karen, Jody, yeah, it's absolutely spot on, guys. Half the amount of light is coming in when we reduce by one stop. Okay, and it's the exact same if we go back to this guy. If we go back to, again, at 0, the light meter, when the light meter is placed at 0, it's underexposing this scene. We can see how it's all grey, it's incorrect. So at +1, and everybody's getting in there already ahead of me. Christopher, you're absolutely spot on. Jackie, yeah. Andrew, yeah. We're doubling the amount of light coming into the scene. And doubling the amount of light coming into the scene, we can see the significant difference that it has had on this particular photograph. It's letting in twice as much light, and that means that the scene is now correctly exposed for. Okay? So it's a bit of a tougher lesson, guys. I know this has been probably the most technical lesson that we have had so far. So I do recommend reviewing this lesson in your student login area when it goes up there for you tomorrow. But get used to using your exposure compensation in your semi-manual modes, okay? Find your camera's light meter. It's essential. Your camera's light meter is going to be very, very important for the next lesson as well, as this is what you're going to use as a starting point when you begin to change your shutter and your aperture settings to get the correct exposure in fully manual. Okay, so just to summarize what we covered this evening, we covered a lot in this lesson, okay? And Dylan, you're saying the most informative lesson yet. Absolutely, Dylan. I think the last 4 lessons are really where I suppose we turn the corner, and a lot of students find they get the most out of these last 4 lessons. So, but we had a look at how the light meter works. We had a look at stops of light, and I want you to get used to using those terms, stops of light. Okay, so if you're increasing or decreasing the light, I want you to be able to say stops of light. We had a look at how the light meter works in aperture value mode. We had a look at light meter in time value mode, how it compensates by either adjusting the aperture or the shutter speed. We had a look at issues that you encounter as well with your light meter and how you can compensate for those as well. Okay, we had a look at resolving exposure issues with with compensation as well. Now, I did mention grey cards as well. We'll have a look at grey cards in lesson 8. Okay, my apologies about that, but we'll talk about them briefly in lesson 8 and lesson 9 as well. Okay.